In this video, we're going to look at how marks are awarded for coherence and clarity of argument for the questions on the exam which require fully written solutions. So we're going to do so by looking at a student's R solutions for a specific exam question which is worth 3 marks. So the question is to consider the function n, which takes an element from n cross n and returns an element of n, and it's given by m of ab equal to a times b. So the question is f surjective, is it injective, and you're asked to justify your answers. So this is for 3 marks. Well, let's look at the first answer. Well, the first answer we've got here is really sort of a tragedy. So let's have a look. We're saying here injective equals 1 to 1, elements hit, some arrow, 1 times n, 100 equals 2 times 50 equals 10 times 10. I mean, you might believe that perhaps this means the person understands something about surjectivity, but it's just absolutely unclear, and perhaps they understand here something about surjectivity, injectivity, but it's just absolutely incoherent. So I'm afraid that this is 0 out of 3. So moving on to the next solution, we have that m is a map from n cross n to n with m of ab equal to a times b. M is injective if for all n in the image there exists a unique ab in the domain such that m of ab is equal to n. So already this is an excellent start because there's some notion, so it's explicitly shown that we understand what injective means. So it says here that m of 1n is equal to n, hence this guy is injective. Right. Well, here we have a problem because, of course, this isn't injective and it doesn't match up. So we've got a big problem here. And we're saying here m is injective if all elements in the range. 2 times 3 is equal to 3 times 2, hence not surjective. And again, it's just the wrong conclusion in both instances. So in fact, the argument is incorrect, but the setup is good. And so given the setup and given that this is relatively well laid out, even though it's wrong, we would get an exam mark of 1 out of 3 in this instance. So now let's look at another possible solution. So again, the map is well defined, nicely set up. When we let a equals 1, we find that m of ab is equal to b for all n. Hence, this is surjective. So of course, this is excellent. So note, well, what is this? This is, I mean, this is some sort of secret notation, which is just, you know, you can guess that probably the person knows, but I mean, it's just, how does this relate? What is everything? It's just unclear. So we've lost some coherence and some clarity here in this solution, and this would look like a 2 out of 3. So moving on, we have the following solution. So everything is nicely defined here. We're saying that m is equal to ab. Well, this is certainly a problem because I mean, this is like, I mean, it's not clear what a is, what b is. M is a function, is it not? What is this? This is absolutely wrong. So again, we've got, what does m equals 2 times 2 mean here? I mean, that's just simply not right. So even though the explanation sort of indicates that probably whoever wrote this understood that the function was not injective because these guys get mapped onto the same elements, and so the sort of correct conclusion is drawn here and explained, but the way this is laid out just illustrates a fundamental misunderstanding of this notation. So finally, we have an argument here, m is surjective because every natural number is in the domain. but again, there's this misuse and misunderstanding of notation. So in this instance, it's quite a good answer. However, there's just this thread of misunderstanding about both notation and so this guy. So I mean, technically what's written, of course, is incorrect, and so unfortunately, this only gets a 2 out of 3. Now, moving on to another answer, so we've set up m, the function, very nicely, and we say it's surjective as m of 1n is equal to n. But of course, this is an error. Is this so what we should have here is that we're putting the ordered pair 1n into the function. Okay, so this is for all n. Good. So this is correct. The function is not injective, as natural numbers can be reached in many ways. So it's a little loose, but here we see that m of 2, 3 is 6, and this is equal to m of 3, 2. Okay, so this is good. Now notice that here we didn't make the same slip. So of course, you're allowed a slip as long as the argument is coherent and it's not a consistently recurring problem. So this guy would be a 3 out of 3. And so finally, we're going to move on to the model solution. So for all n, a natural number, 1n in n cross n, and m of 1n is equal to 1 times n, which is n. Hence, m is a surjective map. Note that m of 1, 2 is equal to 1 times 2 is equal to 2 is equal to 2 times 1 is equal to m of 2, 1. But 1, 2 does not equal 2, 1. Hence, m is not an injective map. So this is absolutely a 3 out of 3 because it's completely coherent. It's written out with full sentences. So notice that mathematics can form part of the sentences. So we had some longer answers earlier which used full sentences very well, but we can also write a sort of neater type of solution by putting a lot of the sentence into mathematical notation. And so this is the sort of way in which an exam question might be marked for coherence and clarity.